So consider this given problem statement. So here we have a equation that is square root of 3 times cos x squared, that is equal to square root of 3 minus 1 times cosine of x plus 1. So the number of distinct solutions when x is in the first quadrant. So number of distinct solutions we need to compute, right? Now here, this is the given equation here. So first of all, I'll write the given equation as it is, and after that I'll be resolving this one. Now this one can be written as square root of 3 times cos x squared as it is, and this I'll just multiply the square root of 3 times cosine of x, and here minus cosine of x plus 1. Now I'll subtract this square root of 3 times cos x on both the sides. So this will result in square root of 3 times cosine of x. So I've subtracted here, and on subtraction this will be eliminated, and this one can be written as, or I will just shift the other terms also. So here I can write, on adding cosine of x, here I'll get cos x minus 1, right? And finally the RHS turns out to be 0. So when I added cos x, cosine of x on both the sides, this got effectively 0, and then subtracted 1 on both the sides. And finally this is the equation that I'm having. Now from this term, that is this one, square root of 3 cos x square minus square root of 3 times cosine of x. So here it is clearly visible that this square root of 3 times cosine of x is the common factor, and this is multiplied with the same quantity, and here this square root of 3 won't be there because this is already in the part of the common factor. So square root of 3 cos x multiplied by cos x, that is square root of 3 times cos x squared, and this one minus 1 as it is, plus from here 1 is the common factor, so this one can be written as cosine of x minus 1. Now, so these are the given expressions. So here cosine of x minus 1 is common, and from this square root of 3 times cosine of x plus 1, it is equal to 0. Now there will be two roots. So here cos x will be equal to 1, and this is acceptable because of the condition that is given that x belongs to first quadrant. So this is the acceptable solution. But if you observe this cos x as negative 1 over square root of 3, so this one will be rejected. This one has to be rejected. The reason being, it is clearly mentioned here, it is clearly mentioned that x belongs to first quadrant. So therefore this one is rejected. So this is the given reason, and because of this, this particular root is rejected, and the previous one is accepted, again the same reason actually, right? So from this we can say that 1 is the answer. But here the answer is straightforward because it is asking for number of distinct solution. So you have only one solution. So whether you count the number of solution, that is also 1, and if it is asking you the value of cosine of x, that is also equal to 1. So from this we can say the answer would be 1, right? Because in cos x, that is cos x, when cos x is equal to 1, so in the first quadrant only one individual value of x will be satisfied for this one, right? And hence we are having only one solution for x, right? So that's the answer.